the shape of it. This up here, this portion, is considered the base. This is the point that we have our great vessels. This is how you will hear them referred to. They are referred to as the great vessels. The apex is this very blunt, pointed end, like I said, towards the left. The lungs have to accommodate the heart within the thoracic cavity. So within the thoracic cavity, the lungs actually are around it. It's really cool. The size, it's roughly about 3.5 inches here. We get about 5 inches, about 2.5 inches through it. So it really just depends. It would depend upon your shape, your height, your body. All right? This is pretty much the norm. When they say about the size of a fist, yeah, okay, all right, but your fist, okay, so it wouldn't apply straight across the board. Now, the structure gets really interesting as well as very important. One of the things about the heart, well, how do y'all enjoy eating? Yeah. Okay, I kind of like that idea. And wait a minute, it's a muscle. Everywhere else in my body, well, let's think of skeletal muscle because it's very similar in structure. Skeletal muscle will actually fatigue. Does the heart fatigue? No. If it did, it would stop. And if it would stop, you wouldn't know it anyway. Okay? So, the structure of it becomes important. One of the things about the heart, it sits in a very nice covering. In your textbook, it shows the picture of this right here. It looks like somebody, well, it is. It looks like they're trying to represent someone holding a balloon and taking their fist and putting their fist into the balloon, making it surround the fist. Very similar concept for this wall around the heart. It looks as if it's sitting in a balloon. The innermost part of the wall, because that's what they refer to it as, the innermost part of the wall traces the contours of the shape. So if you look at the heart, the innermost wall, okay, known as visceral, because this is viscera, what that means is that wrapping is following every contour of the heart. So as this heart wall, okay, it's called the pericardium because it's peri, around, all right, card for the heart, all right. It has the two walls, the inner, the outer. It's a sac, just like they're trying to show right here with the balloon, okay. It is also anchored. So the heart is sitting in this sac, and the sac is anchored. It's anchored by ligaments to my diaphragm, and then areas to the posterior and the anterior portions. Because we are now in our thoracic cavity. Okay? In my thoracic cavity are my heart and my lungs. The heart is surrounded by the pericardium. This double sac that it sits into, inner wall is my visceral pericardium because it's following every contour. This is also my serous layer. What does it mean for something to be serous? That's from part 1, fluid. It secretes. There is fluid present. The outer wall is termed parietal. This is the portion that is fibrous because it's going to be those fibers that help to anchor it in place. The structure that gets created, it creates the pericardial around cavity. Because if I have the double wall, that is creating a space that's going to be present. That space, this cavity that gets created between the inner and the outer wall contains pericardial fluid. Very important.
So if like somebody had like pericarditis, would that cause like the fluid to be inflamed, or would it be the fluid and the outer portion?
A lot of times when they say the pericarditis, this means not enough fluid is getting created. It's in the pericardial cavity, so therefore the pericarditis. And from what I understand, very painful. Okay, they sometimes have to go in with needles, whatever the case might be. Treatable because I'm not sure how. I don't know if it's like antibiotics or other fluids.
Like anti-inflammatory or like.
Okay, so the inflammation of those tissues. Okay, so the inflammation between that inner and outer wall. And from what I understand, people who end up having that, because the purpose of this fluid, this pericardial fluid, is so that you don't feel every heartbeat. Having this structure of this double wall actually allows for that anchoring while the heart is going boom, 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 boom. Every time it does it, okay? But in the case of pericarditis, where there is inflammation, you feel that heartbeat. And a student who had it in one of my other classes said it was extremely painful.
Were they smokers?
Hmm?
Were they smokers?
No, he actually had it when he was young, like around 12 or 13.
Parents smokers?
I don't know, didn't ask.
It's like average they say for more men to have it like 20 to 50. It can occur acutely or
Or chronic. Yeah, could be something acute or chronic. Is it more common, Brian, in smokers?
Everybody I've always known to have it was a smoker.
Interesting.
Just to quit smoking.
It's interesting. I know it's something that like can be common as you age. You know, like people who end up, well, once again, I think that would go back to being smokers, like the COPD and stuff like that. Yeah. So this sac is very important around the heart, as well as that fluid that's getting secreted. This gross anatomy, if you were to take the heart out and begin to dissect it, okay? Once again, 3 layers. No different than anything else that we've studied. We've always had an outer layer, inner layer, and a middle layer. Same thing with the heart. We have an epi, endo, myo. The epi, the outer portion, that is also what we just learned as our visceral. Okay, so visceral pericardium. It's the serous membrane, and the reason I put this up here, it's mostly simple squamous epithelium. What do you remember about the structure of simple squamous? One layer.
Flat.
They're flat. They look like fried eggs. The nucleus is kind of bumped up in the middle. Those cells are perfect for secreting materials. Therefore, their ability for helping with the serous portion. The inner layer, endocardium, along with like pericarditis, we can have endocarditis, because endo means to the inside, okay? These chambers that we have, they're going to also have a lining. That is our endocardium. Simple squamous epithelium. The other part about it, it covers valve surfaces. Valves. Ever heard of that term associated with the heart? Have you ever thought about your heart valves? Oh, you will now, because it's really nice if they stay good. Because if they don't, they can actually be replaced. Valve replacement?
Pig valve.
The pig valve. And they have the artificial. Always go with the pig. Don't go with artificial. Okay? These valves that you're seeing right here, this little portion, okay, that can actually get replaced. Now, covers the valve surface and is continuous with endothelium of blood vessels. What? What did I say about these? What did I call them? The great vessels. There are valves that lead into each of the great vessels. And the valves get to run continuous with this material of the vessels. The reason for this